Hello everyone, this is a follow-up video for easier instruction for running your LLM and VLM experiments with or without a structured JSON output. So let's see the 8 steps that you should do to run your experiments in parallel, which enables you to scale your experimentations. This is the GitHub repo called ezExperimenter, and you can find two setup for this for using experimenter. The first one is easier one, which is also just a minute. So there's a easier version and like a more advanced version. I already prepared the 1-hour video for more advanced version, and this is the improved version, which is like easier, and they're like, if you have no coding experience, it's fine, you can still run it. To begin, I should mention that I'm using Windows. I have a good GPU, like 16 gigabytes of virtual memory for my GPU, plus 64 gigabytes for my RAM, so I can run many models locally, but still, if you want to use any models locally, just consider the model size. So the first step is to install the Python. Here you can install Python version for your use case. Any version higher than 3.9 is fine. Then you should go and install VS Code, which is the environment that you will do the coding and all of those things. You should download this for your system, and then install Git, which is like, if you skip installing Git, I guess the code will work, but I don't have any machine to test this. So yeah, then you should install Git, and then you should go and get your account for running OpenAI. Or you should get your Firework account. So it's not that much a big deal. For OpenAI, you should sign up for your account and then charge your account, and from this link you can get your API. So basically, with each engine that you want to use, you should get the API, which is a like set of characters next to each other. This is a key to pay for your use. The base URL is this for OpenAI and Firework. Basically, I recommend using OpenAI and Firework for any purpose, for any LLM that you have. Firework is really safe. The engines are really great. It is fast. You can run many open source models, and that's it. So you should get your API, create an account, charge your account, and then get your API. Select your model for experimentation, and you can also use what else? You can use RunPod. This is more advanced. I will skip it. You can also use Hugging Face. You just need to sign up for Hugging Face and then create your API and select your model. So your model is something like this. You can also run LLMs locally. This is Ollama. You should just install Ollama, and then for any model that you want to download, you should just open command line and enter this command, ollama pool, and then your model name. These are more like the details are more covered in the previous video. So this is for you can also use any platforms, any platform, as far as they mention that they are OpenAI compatible, which means that the way that you can send and receive requests and outputs are the same as OpenAI. So basically, API means it's the key that you will provide to the server to pay for to connect your use with your wallet to pay for your use cases. base URL is the address to send these requests. So, and the model is the name of the like model that you want to use. So these are the three things that you should get. And back to this one, when you are done with selecting your model and your engine, you should start designing your experiment. And in this version, there is no need to run anything. You just need to duplicate this. So this is online. You don't need to clone anything. All of the codes are already prepared. So for example, I want to test Firework, and this is the base URL. This is the Firework API key. You should enter your API key in a .env file. I will show you. And this is the path that you want to save your experiment in the future. You can have as many as experiments you want to test the temperature, system prompt, max token, and basically you will use Excel files to read your experiments and send them. So this is batch size. For batch size, you will send multiple requests in parallel. So it means that instead of just sending one request, waiting for the answer and then send the second one, you can send 30 requests at once and get the outputs, and then go with the second batch of 30 requests. So this is the model name that you should enter. If you have image column, you should put the path to those images separated by comma. So this means that you can provide multiple images to the system. Also, this is a cool one. So if you want to get a structure output, you can define Pydantic objects. For example, you can define, I don't know, radiology report. And for each, so this is what I want to evaluate, a radiology report. And this radiology report can have features. So one feature is modality, and the type is a string for sure. And if you press this button, this means that you can get list of modalities if you want to have multiple labels for this object, which is not the case for me. So I want it to be just one string, not list of strings. So the field description is the modality of radiology exam, and you can limit it to have CT separated by comma, MRI, I don't know, ultrasound, and anything. And then you can add this field. As you can see here, we can have field. Also, you can define another Pydantic called radiologist, and this radiologist can have name, which is a string, name of radiologist who reported this image. This is not the one. So as you can see, now we have for radiologist, now we have name. And we can also, let's be creative, a name of children. I don't know, is it possible to include name of children? Sorry, yeah. So name of children is actually list of strings. So each radiologist can have multiple children. So it is just imaginatory. There is no data about radiologist like son or daughter. So anyway, this can be a list of strings, name of the children. And then, so what I wanted to show is that then I can get back to radiology report, define radiologist info, which is a new object, and the type of this object is a Pydantic object, which can make hierarchical leveling for extraction. This is not a list. Information about radiologist who reported this exam. And that's it. So you should select the object. So I want to define radiologist as the feature of the radiology report. So yeah, it's really cool. Now you can have like hierarchical levels for extraction, which is really cool. I have an example in the previous video, so you should, I guess you should go over that video also. So when it is done, you should just provide the generate the code. Then you can continue with creating one example. So this is a folder. You should create a folder. Then let's see the Excel file. So this is the Excel file. This is the title and abstract of papers, and I want to extract some information about these machine learning papers in medicine. So I prepared the input as title and then abstract, and that's it. So yeah, it's done. The only thing that is needed is to I should also get the path to this file. So if you press Ctrl+Shift+C, you can get the path. So I should provide the path to this Excel file. Basically, you can't like read columns because I haven't uploaded this Excel file. So let's get back to this folder and see how I can like run these things. So I should create, I should open this with VS Code. In Windows, when you install VS Code, you have a button like Open with Code. Then I should create one file, new file with like this is a Jupyter notebook. Let's save it here with the name something. So basically, all of the codes that you should run is here. So this is the code for getting the codes that I prepared for you to run your experiments. This is for transferring the codes from the ezExperimenter to the main folder so your engine can read that. This is for installing the package. Let's do this. So the first thing to do is to open up the open a terminal and then press Python -m venv and venv. This will create a virtual environment for us. So as you can see, it created a virtual environment. And now I should select this virtual environment as the engine for running the codes inside this notebook. So I should go from here. You should see venv. So this is the this is venv script. So this is the virtual environment we created. So as you can see now, my engine is venv, the one that I created. And then you can copy and paste these lines. So this line will clone the code, my code. This will transfer it to the path of the folder instead of being in a subfolder, and this will install required package. Let's see if anything happens. The pop-up window is due to the fact that Python is not inherently supported. Okay. It's somehow odd. So let's do this. Let's venv /script /activate, and then we should I should also add the IP kernel here. You should copy and paste this. It provides the solution for you. Oh, I see. The problem comes with my VPN, not with, let me turn off my VPN. So you will not get this error. You just, when you run it, it is like pressing install and it's done. As you can see, it's done. My VPN was on, and when my VPN is activated, I can't install any module from Python. So yeah, you will not see this error. So yeah, it's currently installing IPI kernel to run code in a notebook. VS Code will do this for you, and then it will start cloning the code I prepared here. You could also download the code as a zip file and then put it here. Yeah. There are also other things that you should mention. For example, you should provide the name of the column that you have. It's not hard to go over them. You should provide the heading of the column that you prepared your from input data. So yeah, it's not that much hard to do that. In my case, so as you can see, it started. So it's done. It already cloned all of these codes. Now you can see my code for generating the output, handling the experimentation. This is the test. This is the SRinlit application. What else? This is the app.py. You can also run this app.py locally. It will open up. It will open something like the environment that you previously saw. So this is the requirement text, which includes all of the required libraries for installing. And as you can see, all of these things are installed. One of these things are not installed, which is not important. You can just skip it. So then you can go and continue running the code. So yeah, you should provide the prompt column name here. If you have an image column, you should provide the column name here. So these are the libraries. Then you will import all of your libraries. Let's see if any error happens now. Let's run this. Okay. Okay, I see. I will update this. You don't need to define all of these versions. You can also remove all of these versions. It shouldn't cause any error. Oh, I see. Okay, again, I turned on my VPN. So the problem is that, okay, forget it. So it should work now. Sorry. I just turned out the VPN to show you the application environment. Yeah, it's working. Again, you shouldn't see these errors. So this is the API. So yeah. So you should you have example.nv here. You should rename this and remove the example. So the name is just .nv. And these are the like APIs that you get from servers. You should just copy and paste them here. So it's done. If you don't change anything, there is no need to also update the code. So it's done. All of the packages are successfully installed. Now you can import all of these codes. So these are the Python packages. These are the codes that I prepared. If you are a developer, you can go over them to see my logic. This function will handle experiments. This function will handle sending one request in parallel. And this is the test LLM function if you wanted to test it out, and if you are a developer, if you know like some basic thing about. So you can also run the same environment locally. Let me show you. So you can press streamlit run and then app.py. Streamlit. Yeah, for easier use, you can also put a sign here and then run like streamlit run app.py. And when you run this, you can see that the same environment would appear. And the cool thing about this environment is that you can actually now read the column names. There is no like big point. Sorry, you should remove these things. So now you can get the column names here. And it's the same environment. You can get the code and you can continue running these things. So if you change the name of your open API key, you should change it here. I'm talking about these .nv. I'm talking about these keys when you get those keys from their website. So that's it. You can also run the same environment locally, or you can use like the online version. There's no big deal, and then it will do all of those experiments. I already test this out for using it with images, with multiple images, with image and structured output, and with like structured outputs with Pydantic. So it will work if your model supports these kind of things. You should use vision language models to ingest images. Some models, like nowadays, many models support JSON schema to get the structure output. So yeah, it's done. Then you should just run your code, which is here, and this is the code. And this will validate your API if you correctly defined it. And sometimes, this is the last thing, sometimes you should, when you define the .env, press Ctrl S or save it, and then restart your kernel, because sometimes it is not loaded inside the environment. So yeah, keep safe, and I hope this can help you accelerating your research. Also, I will prepare easy fine tuner and ezExact, which is a like advanced tool for extraction. Probably you should also see the longer video. For some reasons, it has more explanation. It is a like example of doing these things step by step. Yeah, keep safe.